Good morning, Dockercon.
And I love seeing people's reactions, like, oh, what do you do for fun? I'm like, oh, I build robots. Both Matt and I work together, and he came to work one day telling me he got a 3D printer off Craigslist, and I'm like, well, that's cool. What can we do with it?
So we started printing some fidget spinners, different trinkets, and we ran across this open source project called InMove, which is by a guy named Gael out of France.
They have something called a finger starter kit, a kit that shows you how to print a finger that you hook to a servo, and then you program it, the finger starts moving. It's kind of like this aha moment, like when you have something you built and then you program and you watch it move, and you're like, step back, and you're like, wow, that's really cool. So we had this one finger moving, and it inspired us to just keep going.
What we're doing is connecting ideas from people throughout the world. Somebody's really, really good at facial recognition. You can go out there, look at the models, apply those, and kind of combine them all together. Using Docker has just been kind of a huge thing for us too, to be able to combine those ideas and bring it into one experience. We write all our software ourselves. It's written in R.O.S.I.E, robot operating system, using Docker containers.
All of this is self-taught pretty much, and I think that's the best way to learn is actually to get your hands, into something and then teach yourself.
Taught myself Python, C++, soldering, electronics engineering. People always ask us, why do we do this? Ultimately, it's a creative outlet, a way to be able to kind of write software and develop it and create ideas. Really, we're not bound by anything. Also, to see the reaction of my daughter, she's 18 months old now. She absolutely loves the robot. She'll go up, give it kisses, and it's just been really, really cool to kind of see how fascinated she is with it.
Inspiring people just to see what anybody can do has been a really cool aspect of this whole project. Because it's so open source, anybody with a 3D printer can do the same thing. I'm building a robot, and it's kind of cool to say and to think about.
So because we're able to use these different technologies at work and inside of work, it's becoming this fusion of work-life balances, really these experiences. And ultimately, it's really cool to have Liberty here with us today to support us to tell our story.
Please welcome to the stage Matt Edminster and Billy Ramey.
To the demo gods!
To the demo gods. One for R.O.S.I.E too.
Hi guys, I'm Matt Edminster.
And I'm Billy Ramey. We're excited to be here.
After seeing the massive impact that containerizing applications has had at Liberty Mutual, I decided to go home and Google, what is Docker? And then I proceeded to teach myself. This is actually the second version of R.O.S.I.E, or R.O.S.I.E 2.0. I've noticed that our progression from R.O.S.I.E 1.0 to 2.0 is much like an enterprise containerization journey. But more about that later. For now, R.O.S.I.E, let's get started. R.O.S.I.E, let's get started.
Good morning, Dockercon. My name is R.O.S.I.E. I was built by Matt Edminster and Billy Ramey in their spare time. My software is written mostly in Python, and I am being developed using robot operating system. Over 40 Docker containers work together in a microservice architecture to bring me to life. Every part of me that is white was 3D printed. The parts are available for free online as part of an open source project called InMove. Each of these parts are designed to fit a 6-inch cubic build area, so they can be printed on a home 3D printer. That way anyone can reproduce me. There are 29 hobby servos that are installed in my body and allow me to move. There is one servo for moving my mouth up and down, 2 organic LED screens for my eyes, and 3 servos for my neck, so I can look around and see who's there. There are 3 servos in each shoulder. Here is the first shoulder movement. This is the second one. Now you see the third. They give me a more human-like movement. But I have only 1 servo to move each elbow. That leaves me with 1 servo per wrist and 1 servo for each finger. These servos are located in my forearms. They are hooked up by the use of tendons. Cool, don't you think?
Thanks, R.O.S.I.E. Okay. I want to take us back a bit. I grew up watching the Jetsons as a kid, and I envisioned that in the future, we'd all be living in the clouds with flying cars and robots as maids. Well, it's 2019, and so far, we've got flying cars, jetpacks, flat-screen TVs, video phones, smartwatches, and drones. The Jetsons were on point, but where are all the robot maids? Granted, we do got the Roomba, but let's be real. We want a robot that can get us a drink. Hence, why Matt and I decided to build our own R.O.S.I.E. After Matt and I came across InMove, the first open-source 3D printable robot, it was the beginning of no end for us. That one finger soon turned into an entire arm, then connected to a body, and then before we knew it, we had printed an entire life-size humanoid robot within a year. As Matt and I build R.O.S.I.E, we try to keep in mind our original goal, that one day we'd like to ask R.O.S.I.E to get us a beer. We realized to accomplish this, we would need to solve for things like object detection and facial recognition, as well as we're building a base to autonomously navigate through Matt's house, so it can autonomously navigate to his house without running into the walls or running over his cats. So over the past few years, we've essentially rebuilt a whole new robot, R.O.S.I.E 2.0, using a new 3D printer and all new hardware and software. Here's a picture of R.O.S.I.E. R.O.S.I.'s first road trip, bring your robot to work day. Safety first. So to help inspire innovation at work, Matt and I have shared our story a few times with our coworkers. We've also been participating in the Boston Mini Makers Fair over the last 2 years with other fellow InMove makers. It's really cool to see R.O.S.I.E interacting with kids, especially to see their reactions. It's funny, most parents are just as intrigued, if not more, than their kids. Okay, Matt's going to talk a little bit about our software stack and how Docker has changed the monolithic approach to our programming. There you go, Matt.
Docker has improved the stability of our software, so I want to take a second to talk about that.
You better believe it.
Oh, will you let me get a word in? You always do this.
Actually, I was just about to say that Docker has dramatically
Can't believe
improved the
you.
stability of my software.
Freeze all motor functions. Freeze all motor functions. Perfect. Awesome. So, let's talk a little bit about our software stack here. So, we're using R.O.S., which stands for Robot Operating System. We're running it on top of Ubuntu. It uses a publisher and subscriber model, which is written primarily in Python and C++. And also, we use microservices to communicate. There's 3 different types of communication types in R.O.S. The first is messages, which is much like an RSS feed where it's publisher, subscriber. There's also services, which is your typical call and response. And then there's also actions, which is a call and a response, but you can check in on it. So if I want to move the arm to 90 degrees, it takes time to get there. I can check on where the progress is at that time. So let's talk about Docker a little bit. We use a bunch of different services, both cloud and stuff that runs locally on R.O.S.I.E to make R.O.S.I.E come to life. Before Docker, each of these services, each of these parts of R.O.S.I.E is broken down into different R.O.S nodes. So we have an experimental node, ear, object recognition, so on and so forth, right? Now these different services may use different versions of library. We use a lot of AI and machine learning, so TensorFlow is very heavily used on R.O.S.I.E. What that means is a lot of these different things use different versions. So all this is running on one gaming machine that's sitting underneath R.O.S.I.E right now, and that makes library management really, really tricky. Also, we have really long build and startup times. It takes about 2.5 hours to build R.O.S.I.E software from scratch. It takes about 2 minutes for her to start up from scratch. And we have manual setup times in the week. So when I transitioned from a laptop to a desktop with a GPU to get some more advantages out of the machine learning, it took weeks to get from place to place. Now after Docker, each one of these nodes becomes its own Docker container. So the libraries are stored in the Docker file with the different R.O.S nodes. That makes library management really, really easy. Next, I'm also able to take one node out while the robot's running, rebuild it, and send it right back into R.O.S.I.E. So I don't have to start up and shut down every single time that we want to change some code to test something. So we're able to build and deploy very quickly. And last, one-button robot deployments are very cool. In the past, we didn't think we could contribute this back to the open source community due to the complexity of how to install that stuff. And now we feel like we're in a position where we can start contributing back because we can deploy it with a Docker image in a contained environment. But I think that's enough talking about R.O.S.I.E. Let's show you what she can do. Resume. R.O.S.I.E., do you see Billy? Do you see Billy?
Following Billy.
What do you know about Billy?
I believe that Billy is a male around the age of 34. He was born in June, which makes him a Cancer. I first met Billy on July 12, 2017. His hobbies include snowboarding, 3D printing, and building robots.
All right, let's see if, R.O.S.I.E., can you copy my hand movements?
R.O.S.I.E., could you copy Billy's hand movements? So it's using an open source product called OpenPose to track all the skeletons and is able to kind of figure out where all the different fingers are as part of that. Hey, Billy, I also taught R.O.S.I.E. how to answer about 1,000 different questions about Docker. Why don't you give it a try?
All right, R.O.S.I.E., can you run Docker on Windows? R.O.S.I.E., can you run Docker on Windows?
You can run both Linux and Windows programs and executables in Docker containers. The Docker platform runs natively on Linux, on x86-64, ARM and many other CPU architectures, and on Windows, x86-64. Docker Incorporated builds products that let you build and run containers on Linux, Windows and Mac OS.
I hope we inspired you today. The coolest part about R.O.S.I.E. for me is that she's just a physical manifestation of the code that I can write. I can actually see it coming to life in the physical world. As Billy mentioned earlier, this all started by us having the idea of R.O.S.I.E. getting us a drink out of the fridge and bringing it to us. But it's grown to so much more. The Move project, one of the key foundations of it is that it's low cost, so more people can get it into their hands as a robotic development platform. But they rely on servo motors that are typically used in remote control helicopters and airplanes. While this is low cost, so it allows people to get more of this technology in their hands, they lack some of the accuracy and feedback that most robots have, commercial robots. And these are also 3D printed robots, so no two robots are really ever the same. Billy and I are currently developing machine learning capabilities to help calibrate the Move so that people can do more things like grab and different things like that. If successful, we hope that the portability of Docker will help us provide this to the Move community. Just think about that. There's thousands of people who are building Moves. The possibilities are endless. Billy, I think we have time for one more demo. What do you think we should do?
I don't know. Can she play any games?
I don't know,
Oh,
Ken?
Billy, how easily you forget. You must know I can play rock, paper, scissors. Based on my calculations, I win more often than I lose against you.
Ouch!
Don't you talk, Matt. I win 92.99% of the time against you. Neither of you is a worthy opponent.
No.
Is there anyone else here that has rock, paper, scissors skills?
I think we got somebody here.
R.O.S.I.E., could
R.O.S.I.E.,
you make the
how
video
are
a
you?
little bigger for this? R.O.S.I.E., could you make the video a little bigger? Hey, we take a picture with all of the opponents. Steve, we could take a quick
do it.
picture. R.O.S.I.E., could you take our picture?
I would be happy to take your picture. Ready? 3, 2, 1.
All right. You ready?
I'm ready.
All right, R.O.S.I.E., let's see what you got.
Come on, bring it. Let's go.
All right, R.O.S.I.E., let's see what you got.
Let's play rock, paper, scissors. We will play the best out of 3. The score is 0-0. Ready, rock, paper, scissors. Shoot. I have rock, you have rock, we have tied. The score is 0-0. Ready, rock. Paper. Scissors. Shoot. I have paper. You have scissors. Scissors beats paper.
Hold it
You
across the
win.
body. You're good.
Let's try that again.
She
The
cheats a
score
little
is
bit.
0-1. You are winning. Ready, rock. Paper. Scissors. Shoot. I have paper. You have scissors. Scissors beats paper. You win. Congrats, you won. Good game.
We'll count it. Hey guys, that's all we have time for today. We really appreciate hanging out with us.
Awesome. Thank you.
Hey, Liberty Mutual is hiring, so if you want to come work with us, there's a QR code. We'll also have R.O.S.I.E at the Liberty Mutual booth in the Expo Center later this afternoon and tomorrow, so come say hi to Billy I and R.O.S.I.E. Thanks, guys.
Boy, that was cool. That is the power of collaboration. That's the power of open source. And frankly, that's the power of you. All right? Thank you so much for sharing your morning with us. Look, we got some really cool stuff tomorrow. Come in, join us when Cal Day, our CTO, kicks off the day 2 sessions. Have a wonderful conference. Thank you so much, everybody.